Hello friends, Namaste. I am Nitin Pokarkar. I teach chemistry. So friends, in 11th standard we learned about states of matter. Mainly there are three types of states of matter, that is solid, liquid and gas. These three states of matter are interconvertible by the exchange of heat, and as well as we differentiate these physical state with reference to some key points like volume and shape. Then with respect to effect of temperature and pressure, then with respect to motion of or movement of constituent particles, as well as force, interparticle force. So friends, today we are going to discuss some more detail about one of the physical state of matter, that is solid state. Now we know in case of solid, whatever interparticle force is there, that interparticle force is strong one. And since this interparticle force strong, these particles occupy fixed position. They occupy fixed position. Since they occupy fixed position, their volume and shape is definite. This volume and shape, it change slightly with change in temperature and pressure. There is very small effect of temperature and pressure on the volume and shape of shape of solid. So these are some characteristic points of solid. In case of solid, interparticular forces are stronger one, hence their movement or motion is restricted, and these constituent particles, they occupy a fixed position. Since their position is fixed one, volume and shape is definite one, and this volume will change only slightly with change in temperature and pressure. So this is the characteristic properties of solid which we discussed already. Now we move towards the types of solid. What are the types of solid? Now friends, consider an example of granular sugar or sodium chloride salt, glass, rubber. So these are some examples of solid. Now friends, if we compare some properties of solid with respect to these examples, then we find that, suppose in case of granular sugar, if we apply force on it, then that granular sugar, it does not compress, or if we stretch it, it cannot stretch. Similarly, if we form, in case of rubber, if we apply force on it, then that rubber stretches. Means these particles, these substances are solid, but some substances, they does not follow, they does not obey all the properties of solid. So we can classify these particles, these solid, into two types, that is amorphous solid and crystalline solid. Let us discuss one by one. In case of crystalline solid, the arrangement of particles is regular. It is periodic also. Whatever particles are there, these particles, they arrange, their arrangement is perfect one, and it is periodic also. Then in case of crystalline solid, this arrangement is long range arrangement. So if we move about the arrangement of solid in the crystal, then we find that this order is long range order. And since this arrangement is regular one, whatever interparticle force is there, that interparticle force is fixed one. And to break this force, same amount of energy, same amount of heat is required. Hence, crystalline solid have sharp melting point. They have sharp melting point. Instead of this, these crystalline solid are anisotropic. We discuss this property later on. Now in case of amorphous solid, the arrangement of particle is not regular, even periodic also. In case of amorphous solid, arrangement of particle is random. Since the arrangement is random one, irregular one, whatever forces are there between the particles, it is not same everywhere. Hence, to break these forces, various amount of heat is required. That's why in amorphous solid, the melting point is not sharp one. And this particle, they show, amorphous solid, they show a characteristic property which is isotropic. Means amorphous solids are isotropic and crystalline solids are anisotropic. So let us discuss these two properties, that is anisotropic, what is anisotropic and what is isotropic solid. Okay friends, now we are going to discuss about the two properties, that is anisotropic and isotropic. So for this, observe these two figures carefully. Let me denote this figure as A and this figure as B. So from this figure or from this arrangement of the constituent particles, can you identify which one is the crystalline one and which one is the amorphous one? So A is very good. You better understand. So A is crystalline and the B arrangement is amorphous. So in this diagram, in crystalline solid, the arrangement of particle is regular one, and here the arrangement of constituent particle is irregular one. Now if we observe the arrangement of constituent particle in different direction, Remember what we are going to observe? We are going to observe the arrangement of constituent particle in different direction. So for example, if we observe the arrangement of particles in this direction, so AB direction. Similarly, we observe the arrangement of particle in CD direction. And if we observe the arrangement of particle in this direction, denoted as EF. So what we observe, in different direction, the arrangement is different one. Means if we go through the direction AB, we get all small size particles. If we study the same crystal, same substance in CD direction, then we get only large size particles. And if we study in EF direction, then we get different results. So from these three different directions, we get different arrangement. And remember my friends, in crystalline substance, the properties like refractive index, then electrical and thermal conductivity, so these properties are different in different directions, and this phenomenon is called as anisotropic. In case of amorphous substance, the properties like refractive index, conductivity are given same magnitude in any direction, since the arrangement of constituent particle is not fixed, which is irregular one or random one. So such a property is called as isotropic, which does not depends upon or independent on direction. So I hope you better understand what is anisotropic and what is isotropic. Well friends, now we understand these two properties, that is isotropic and anisotropic. Now friends, in crystal structure of different solids, similarity or dissimilarity is observed by some properties like isomorphism and polymorphism. Now let us see what are these two properties. Isomorphism and polymorphism. Let us see isomorphism first. So to understand this, let us take an example. NaF and CaF, or we can take an example of magnesium oxide. Different atoms are there. Now in this example, these two substances, they have same structure. Since they have same structure, if we observe the atomic ratio in case of these two compound, in case of NaF, there is one atom of sodium, one atom of fluorine, so atomic ratio is 1:1. In case of magnesium oxide, one magnesium atom is there, one oxygen atom is there, so the atomic ratio is 1:1. Means isomorphism, it is the phenomenon which is shown by such a compound which have same structure as well as same atomic ratio. Consider another example, that is NaNO3, sodium nitrate, and calcium carbonate, two different substances, they have same structure. If we determine their atomic ratio, so one sodium atom is there, one nitrogen atom, three oxygen atom, so the ratio is 1:1:3. In case of calcium carbonate, one calcium atom is there, one carbon atom and three oxygen atom, so the ratio is 1:1:3. In this example, different compounds are there, but their structure is same and their atomic ratio is also same. Since they have same structure, they are called as isomorphs, and the phenomenon is isomorphism. Iso means same, morph means form. They have same form as well as same atomic ratio. These compounds are called as isomorphs. Now, polymorphs. Poly means many and morphs means form. That is many form. Let us discuss with example. Consider an example of beta car, then alpha car, then so these are the compounds which contain SiO. These contain SiO. Then let us consider an example of graphite, diamond, then your fluorine. These are various forms of carbon. Then contain crystallobite. Carbon has the constituent particle. Now, in case of polymorphism phenomenon, here same compound have different structure. Same compound have different structure. That's why they are called as polymorphs. So in this example, compound is same, but forms are different. Here, element is same, but it exists in different forms. This phenomenon, polymorphism phenomenon, is observed in case of different forms of element. It is also called as allotropes. So these are the allotropes of carbon, which we study in 11th standard. Allotrope, different allotropes of carbon, and the phenomenon is allotropy. So when polymorphism is observed in case of element, then it is also known as allotropy. So these are some properties which are shown by solid. Now we are going to discuss the types of crystalline solids. The first type of crystalline solid is ionic solid. Now we explain these solids on the basis of some properties. So the first property is particles of unit cell. In case of ionic solid, particles of unit cell are cations and anions. Now you know that cations are positively charged particles and anions are negatively charged particles. These two particles, they bind together by a force, that is interparticle force between these ions is the electrostatic force of attraction. This force of attraction we call it as ionic bond also. Since this force is stronger one, ionic solids are hard as well as brittle. Since the interparticle forces are stronger one, they have high melting point. The range of melting point of these ionic solids are in between 600 degrees Celsius to about 300 degrees Celsius. These ionic solids are poor conductors in solid state, but remember, they become good conductor when melted or dissolved in water. What happens here? When we melt these ionic solids, then the ionic bond is break up and ions are formed. Since ions are formed, they conduct electricity. In case of solution, when we dissolve these ionic solids into suitable solvent, then it is converted into ionic form, and these ions, they conduct electricity or heat. And the example of such ionic solids are salts like sodium chloride, calcium fluoride, magnesium sulfate, calcium chloride, etc. Now the second type of crystalline solid is covalent network solid. In covalent network solid, the constituent particles are atoms. These atoms are bind together by covalent bonds. The covalent bond is the interparticle forces which exist between these atoms. This covalent bond is again stronger one, hence these types of solids are very hard. Since the force is stronger one, melting point of this compound also high, which ranges from 1200 degrees Celsius to about 4000 degrees Celsius. These particles, they do not possess electrons, that is delocalized electrons. That's why they are poor conductor of electricity. There are some exceptions for the electrical conductivity. For example, graphite is good conductor of electricity, though it is covalent network solid. In case of graphite, which we already studied in 11th science, the hybridization is sp2, which possesses multiple bond. It has delocalized electron, and this delocalized electron can conduct electricity. Diamond, it is good conductor of heat. The example of such a covalent network solids are graphite is there, diamond is there, silica is there. Now we move towards the third type of crystalline solid, that is molecular solid. In case of molecular solid, the name itself indicates constituent particles of unit cell are molecules. Now we know that the molecules, they may be polar, they may be non-polar, or they may be hydrogen bonded. So depending upon the nature of these molecules, different forces exist between interparticles. Like in case of non-polar molecules, London forces are there. In case of polar molecule, dipole-dipole interaction or dipole-dipole forces are there. In case of hydrogen bonded molecular solid, hydrogen bond is there. Now since these forces, these London forces or dipole-dipole forces or even hydrogen bond, it is not strong force as compared to ionic solid or as compared to covalent network solid. The hardness of these molecular solids are soft one. These are soft one. So it results into their lower melting point also, which ranges from minus 272 degrees Celsius to about 400 degrees Celsius. These are poor conductors of heat and electricity, and example of such molecular solid are your ice, benzoic acid, then ammonia, HCl, Cl2, H2, O2, etc. in solid form. Then the last type of crystalline solid is metallic solid. In case of metallic solid, the constituent particles are metallic ions in sea of electron. So the metallic bond exists between the metallic ions and the sea of electrons, or we can say delocalized electrons. The attractive force between these cations and mobile valence electrons are the interparticle force which exists there. Hardness of metallic solid is variable. Is in some metallic solid hardness is soft one, and in some metallic solid it is very hard also. Melting point of this compound, it has wide range, which is in between minus 39 degrees Celsius to about 3400 degrees Celsius. All metallic solids are good conductor of heat as well as electricity, and example of metallic solids are metals like sodium, magnesium, copper, silver, gold, etc. So this is about the types of crystalline solid. 4 types are there, which we explain on the basis of constituent particles, then what interparticle forces are there, about their hardness, about their melting points, and their electrical and thermal properties with examples. I hope you understand all the types of crystalline solids.